Hi everyone. So here is the workflow for doing volumetric calculations inside Cyclone 3DR using data from the Elios. So if I just open my folder here, I'm going to drag and drop a LAS file into Cyclone 3DR. This LAS file can either be from the drone or can be from Far Connect. If the stockpile hole is more than 100 meters of length, it's a good idea to post-process in Far Connect to correct the drift. If the size or geometry of the area is under 100 meters of size or length, then the drift factor won't be as much of a factor when it comes to placing the floor and taking a reference for doing stockpile. So in this case, this last file is still quite small, but we also processed in for Connect to correct the drift. So when importing the last file into Cyclone 3DR, you have the option as well to reduce the number of points. In this case, for most stockpiles, we don't need that much points. This last file is quite small, so I can either choose to reduce it or not reduce it. So in this case, we'll just reduce it to 4 million points, and I just click import. And it imports quite fast into to Cyclone. So there's a few things we can do before we start getting into measuring the volume. I'll just change my view here on the side so I can rotate around. If I go to the cloud group, I can select the stockpile. I can then also go to the representation. In the representation, I usually choose smoothing and also the color as well. So that produces kind of like an eye dome effect inside Cyclone 3DR. And then we zoom into our point cloud, we can also see our volumes inside. So it's just a nicer way to be able to view and see the representation of the last file. So next, what we want to do is we want to be able to basically extract the stockpile and also the floor elements inside the last file with and remove the remaining of the building that we don't need actually, or which could adversely affect the volume that we want to calculate. So here inside Cyclone, there's a nice tool in the cleaning tab called split ground points. So if I select the point cloud, I go to split ground points. So that will basically split the ground away from the rest of the building. And it's really the ground and the stockpile is what we need. So in this case, we can adjust the max slope of the terrain. So the max slope is kind of based on the angle of which our stockpile material is set. In this case, I'll set it to around 70 degrees or so. It may take a little bit of trial and error to make sure that we don't lose any of the points, or we try to maximize the amount of ground point detection on the stockpile. Uh, and for the extraction grid size, I'm going to set that to um, uh, zero 0.1 of a meter. So I'm also going to check for any noisy points. When we do fly the drone in this environment, sometimes we can also kick up some dust from the environment, or the environment itself might be already heavily in dust. So it's also nice to be able to check for noisy points and remove those points. So in this case, I'm always going to hit preview. So preview allows you to view the change you're going to make without actually saving it for now. So you see here, everything in blue is what we selected or what Cyclone created as a ground point, and everything in orange in this case, or gold, is going to be the representation of the building structure, etc., though actually we don't need. And you can see it does quite a good job. Even here with this hopper in the center of the stockpile, it eliminates that quite well. Um, so in this case, I can also turn on and off the ground points so we can take a look and see. I think in this case, we've done quite a good job here of being able to take all the ground points that we need to create the volume. So in that case, I'm going to press OK to save that. So here in the cloud group, we've now classified our point cloud into two elements. So we have the ground points and unclassified points. Unclassified points in this case is actually the rest of the shed or the rest of the structure. Um, so from here, actually, we're ready now to go measure our stockpile. So to measure our stock, I'm going to select the point cloud again. I'm going to go into analysis and go to the stockpile tab. In the stockpile tab, I'm going to create a new stockpile. I'm just going to name it stock 1 for now for this test. And here also, we can also add a material name, the material nature itself, whatever it is, whether it could be, in this case, I think it's a lithium stockpile. It could be also grain as well, like soybeans, whatever it is. So in this case, I'm not going to name it. So here allows us to open up the polygon drawer, and I'm just going to draw a polygon around our stockpile. So We can take our time a little bit with this, make sure that we're following around the edges of the stock. In this case, the stock goes up to the outside of the structure of the building itself. So I'm going to clip around there. It comes back along here, around the back of the stockpile. Just keep clicking. And make sure that you also cover enough the floor area. Um, in this case, the floor of the structure itself is flat. We can also do a slope floor, which is quite easy to do also in Cyclone, but in this case, we're just going to create a flat floor. So I'm going to make sure that I have also covered the floor area as well, where we're going to take the reference from for measuring our volume. So I'll just hit return to be able to close that. And you can see now our polyline has selected the material away from the rest of the floor area. In this case, by default, it's going to be set to the ground computation method is going to always be set to the contour of the points. So it's going to contour around the point area, which is actually really good for, let's say, a non-flat floor. You can actually contour it around the non-flat floor. In this case, a flat floor. So I'm going to select in the method, go to a horizontal plane from the lowest point. And we can check that as well here. You can see the floor is in blue, and it's taking a reference more or less from the surface area, floor measurement area here and the front of the stockpile. So if we're happy with that, we just press preview, and now it's doing the computation of the overall volume. So that was quite quick for this area. We can also see that we have our 2D area, our 3D area, our cut volume, our fill volume. Obviously, no fill volume because it's a flat floor. So our total volume then, in this case, is 494 meters cubed. Um, the spiking element here also can be adjusted if we do have even some dust still in the point cloud. We can adjust that as well to remove some of the spiking elements that you might see, which could also add volume to the stockpile, which obviously is a false volume that we don't want to have. So I'm happy with that. We can press OK on that. And then if we have multiple stockpiles within the same area, we can also create another stockpile, go measure that again within the same point cloud or within other point clouds as well that we bring into the same project. So in that case, I'll press that and press OK. Here we can smoothen also our volume. Now we have the volume measured. If you go to stockpile project, we can click down the tab so we can also show the label of the overall volume measurement. Um, I can actually smoothen also the mesh. If I go to surface model and I go to smoothen mesh, I can do a global smoothing on the mesh. On the intensity of smoothing, I can adjust this factor a little bit. So I just adjust it to roughly around 1/3 of the way, and I press preview. In this case here, you can see that we've already smoothed the mesh. Gives a nice representation for creating the report. I'll press OK and exit on that. So for creating the reports, before we do that, we can actually take some nice screenshots and save those and bring it into our report. Um, so in this case, what we can do is go to View and go to Save View. So I can save that view and just say, I can name it 3D. That's a view set, or it's already done. I go to another angle as well. I can create a save view on that too. I can rename that as a 3D2. I can also do a top-down, which is also nice to have for the report. Top-down view like that. Save that. Just go top-down. And we can also activate also the building as well. We can do a nice shot of what it looks like inside the building too. I'll just get myself through the roof section here and save that view as well. Let's do the So for creating the report, I can go into our report tab on the top. I can name the report, add the logo, add the customer's logo, the name of the customer, etc. on the cover front. Um, if I go to the chapter, there's automatically already a stockpile chapter created. In this case, I can also add some of the views that we saved. So the views will be available here and available scenes on the right-hand side. I can literally just drag and drop that into the stockpile project report. So it should populate nicely here. Show also the measurement, also the mesh and the point cloud together. You see all the parameters that we've got as well for measuring that stockpile. If you do multiple stockpiles, they'll have multiple measurements here. I can also create a new chapter as well. I just go to an empty chapter, and then I can also drag and drop in different view saves as well, so the customer can take a look and see at the different viewports, which is quite nice to have. I can add another one here. 3D2 I can do. So they have some nice screenshots as well of the stockpile. So that's how to create a very basic report inside Cyclone 3D.